So you've downloaded UEFN, you want to make something, but it uses this weird ass language called Verse. How the hell do you use it? Stick around and I'll show you. So Verse is a programming language that is developed by Epic Games, currently exclusively for the Unreal Editor for Fortnite. I believe that they have some much bigger plans for it than this, but this is where it's debuting, this is what it currently is the only way you can use it, and because of this it's different. It's got some interesting concepts, some of which make sense, some of them don't. It's not a very mature language. Like when you look at languages like C++, they've been around since the 70s. It had a long time to mature and evolve into what they are today, which is tried and tested and well trusted. But Verse is new, it's bleeding edge, it's for a very niche use case, at least at the moment. What I'm going to be doing is just discussing some of the weirdness of Verse, some of the things that confused me when I picked it up, and hopefully helping you avoid those pitfalls and just get on with making what you want. So just a basic overview of how UEFN actually works in regards to using Verse. So in like a traditional engine, like say Unity or Unreal, like regular Unreal I mean, you'd make a script, then you could add that script to, in the case of Unity, you can add that script into the world, so you just drag it into the scene, so you could just grab it, imagine if this is a script, you could grab it in and it would just become like a game object and you could work with it that way. In Unreal, you can create blueprints, and then you can bring those blueprints into your world. If it's a certain type of blueprint, it's a little bit more confusing, but you can still kind of get the same interaction. Whereas in UEFN, where UEFN is built on Fortnite Creative, so which if you've used that uses devices, actually we can access these devices already. That's a part of what we're going to be using in UEFN, is you're kind of working with these devices, but you can also make your own devices using Verse, and that's where the Verse kind of integration comes in. So just to show an example, like I'm sure if you actually play Fortnite, which I don't, so you probably know a lot more than I do when it comes to the actual Fortnite game side of things, but you've got all these devices here that are from Creative, I assume, and then you can drag them in and they just kind of come in like that. It's very similar to what it would be like in Creative, but we can access the settings for these devices on the right here in the details panel, and we can also hook into these devices with our Verse code. So for example, if you look at these here, where it says user options, functions and events, well, mainly the events, we can actually subscribe to most of these, not all of them, which I'll get onto, but most of them you can subscribe to in your Verse code, so you can listen for these events and then you can act on it in something else. Because our access to the world is quite limited, we kind of have to do most of what we want through the existing devices, but we manipulate them and basically hack them to do what we want. I hope that's explained a little bit more. So let's actually go and make a Verse file, which you do by going to the Verse Explorer. Your layout will look a bit different to mine, but I think the Verse Explorer is always on the top right. You can right click, add new Verse file, and then we can call it whatever we want. Verse has an interesting naming convention. Obviously you don't have to follow it, but it would make things a lot more readable and cleaner if you do. So if you click create, then it will sit for a second and then open VS Code. Hopefully, I might have to open it manually if it doesn't pop up. And then we can see here again, it's a creative device that can be placed in a level, and you get a few little things here, which I'm just going to delete because I'm going to explain it better than they will, most likely, no offense. We see here we've got a function here which is called onBegin, pretty self-explanatory. Don't worry about the rest of it for now, just look at the name, onBegin. So that runs as soon as the game starts. And what it'll do is it'll print out hello world, and then they've got like an inline addition here, so it'll show 2 + 2 = 4. So we can get rid of that. And now this is one of the interesting things with Verse. If you've seen other programming languages, most of them, not all of them, but most of them use brackets like this to show areas of code, like blocks of code. And if you don't have these, then they just won't work. They won't know what to do. Other languages like Python, they work using indentation. People will debate over which is the best. I personally think that, especially as your code gets more complex, that brackets are better, because you can end up accidentally running bits of code that you don't mean to if you get like an indentation wrong, whereas with the brackets there's kind of no two ways about it, whether it's in the brackets or not. It's a lot simpler to follow, but Verse actually lets you do both, so it is entirely up to you, but I think it's much cleaner and much easier to read if you use brackets. So I'm going to be using brackets, but you can just as easily do something. You can do something like this, or you could just get rid of the brackets and rely on the indentation. If we do this, for example, that's not valid. It has to be indented to show that it is part of this kind of code block here. Let's try and do something more than just print something to the screen. One of the things that's a bit confusing in Verse compared to other languages is the declaration of variables. So just to give an example, here we are in a C++ project. Now don't be too alarmed, don't worry, you don't have to understand any C++, this is just a little demonstration. So in a typical language, you would declare the type of variable first. So for a number, that would be, for a whole number, that would be an int or an integer. We would write int and then give it a name, so whatever. And then we just say equals, say 5. In C++, you need a semicolon to end the line. You don't need that in Verse. I think this is pretty natural. You say it's, say, oh, you can do like a string. So string test equals test. Because this is C++, you can't actually quite do that. You have to do std string. But again, do not worry about that. So my point is that this is I think this is more natural, and this is how every programming language does it. And you can change these. You can set. I could go just do whatever equals 6, and that's fine. I could then change it like here. I could do test equals. I could even just steal this line here. Test equals that instead, and that is perfectly valid. Whereas in Verse, it doesn't quite work that way. In Verse, if you try and do the same thing, for example, like int test equals 5, that's just not valid. So in Verse, what we do is we write the variable name first, then we do a colon, we specify what type it is, so we can do int, and then we do an equals, and we actually declare what that is, so we do 5. But the thing with this variable here is if I then go and try and do this, test equals 6, we can't do that, and it will give us some cryptic error. That is honestly not very helpful, and you'll notice that with Verse errors is they're not very helpful. But what this is trying to say is, well, I don't even think it's trying, but what it should be saying is that this is declared as a constant variable. Any variable that we don't prefix with the var keyword is unchangeable. So now I've put a var in front of it, we can now change this variable, but if I try to do test equals 6 again, that still wouldn't work. What we have to do is we have to use the set keyword. So we do set test equals 6, and that works. Now there's a few different ways you can declare variables and what I've just shown. But if you're in a method, then you can do something like this. So by using this, you kind of initialize it automatically. It just figures out the type, so I could change it to also a float, and again that will be fine, it will figure it out. But if you want it to be a variable, you have to explicitly define the type. Like if I did this, for example, it doesn't let you because it needs a type definition for a variable. Change that to float, and then that lets you do that. It's a little bit more confusing. I think that's much harder to read. It takes a while to wrap your head around it, especially if you're coming from other languages that don't work this way, because like you're looking at variables and you're like, what the hell is this? Unfortunately, it gets a lot more confusing than that. How about we touch on getting another device, or getting a reference to something else in the world. So let's say we wanted to access that mutator zone that I just brought in earlier. The way we would do that is we can declare just to give you an example of how it would work, we would declare a variable, and then what we would do is we would go back into the editor, we'd expose that variable somehow in the panel, and then we would be able to drag in a reference into that kind of field, and then we would access it that way. So how do we do that? We need to declare a variable of type of mutator zone, give it a name, mutator zone, and then we do a colon, and we tell it, do we want it to give it a type, a mutator zone device, and I'll show you a place where you can find the names of all of these. You can also just Google it, but there's a file that this will go to that will show us. If we look at this, why the hell isn't that working? So if we read this here, it says mutator zone must have an initializer. So what's this about? So in Verse is what's called a functional programming language, and kind of all we need to really understand is that nothing can be null. What does that mean? In a traditional language, and I'm going to use C++ again because it's a good demonstration. In a traditional language, if we try and use something that is uninitialized, so it doesn't exist, then it will cause an error or a crash, right? So just to give an example, if I make a pointer here, and I don't do anything with it, so that currently I've declared it, it is not assigned to anything, and it's even telling me that it's not initialized, so that is doing nothing. Then, if I try and just print out this variable, just imagine this is print, this is C++ print basically, and you say it's warning me, what the hell are you doing, that's not going to work. And if I do this, if it even compiles, It won't even compile because it won't compile. But if it did compile, what it would do is it would just crash, right? Obviously, when we're running code in Fortnite and Unreal Engine for Fortnite, when we're running our code in Fortnite, we've got people who anyone can go and play our island, right? We don't want them to be crashing Fortnite. That's not a good look. So the Verse is designed to be a safe language. So we have to make sure everything is initialized to something. It doesn't matter if it's not necessarily what we want, it just has to be something. So when the code goes to access it, if we've forgotten to say assign that variable, it won't crash, it will just not do anything. So what we've got to do is we've got to put equals here, just like when we did this with our integer and we assigned it to a number. We've got to assign this to an instance of mutator's own device. We do this, and then because it's a class, we have to do this. We're calling it constructor. So if you don't know what classes are, just basically in modern programming, everything works on the principle of object-oriented programming. So what is that? Object-oriented programming is based around things called classes, and a class is, at its core, a custom-defined data type. I can just do example class. I'm not even using the right naming convention, but let's just ignore that for the minute. And then I can just give this so let's say we're making a class of, the classic one is a car, right? So I'm going to call it a car. And then let's say the car has a color, so we can do color. Give it, say, a cost, an integer. What we could do is we could store a bunch of these in like an array, so just have a group of them, and then we could do all sorts of things with them. I can't be able to think of any examples. I'm sure you could think of a use if, say, like a purchasing system or whatever, right? Or if we're making a shop, we could have a class of, say, item, and you could be like a description or a cost. Same thing, right? We can build our programs to be so much more kind of modular and cleaner by using classes, and that's what, obviously, like every other modern programming language, pretty much, that UEFN is built on. So we can actually right click on this and view its definition, and because of the way Verse works, is we're very far away from what's actually going on. We're writing this code, and then it's being interpreted by the Verse virtual machine, and that's telling the actual game to do stuff. So we're quite far away, so we can't see everything in here. Like, we can go a few classes deep, so it's an effect volume device, and then that inherits from creative device, and then we go to creative objects, and then eventually we just kind of get to epic internal, where we can't do anything else because that's going behind the scenes. The point is these are all this is what I was talking about as well, that you can view kind of all the devices that we can access from Verse in this digest file. There's a few of them, they all contain different things, but I believe all the devices are in the Fortnite.digest file. We can see all the methods we can use, but anyway, I've got sidetracked. My point is that we have to initialize it with a type of mutator's own device. So if we try to do something with this device, it wouldn't do anything because we haven't assigned it to the one that's in the world. We've given it kind of like a blank one we've created programmatically, if that makes sense, so it won't crash the program if we try and do something with it. I hope that makes sense, because the whole concept of things not being null is something that is persistent throughout Verse. Like, you can't access like things without checking that they're null, for example, many times. It can lead to Verse being quite a wordy and kind of lengthy language, but that's just a quirk of how it works, and this is why. It's because we can't go around risking code safety. Verse is first and foremost a safe language that is designed that even if you're an idiot, you'd be hard pressed to crash the program. The worst case is it would just stop running your code, right? That's the point. But anyway, back to this. So the final step of this is we have to add a attribute to it. So we have to do @editable, and what this does is it just tells the editor to make this show up in our device properties, and we can go and actually drag that device in. So let's go see that in action. So if we go back here, click on Verse, and then build Verse code, and then we can go back to the details panel, and then in here we can see in our project content folder here, there's a few folders, but this is what we're making. If we go into creative devices, then we'll see any devices that we've made. I don't think you can move them, I think you're stuck with them in here, but we can see them in here. This is what I've just made. So if I drag this into the world, you see you get like this kind of generic device model, and then here we go, here's our mutator zone. So we can either click here and select it there, or we can use a little eyedropper like that. If you try and do it like this, for example, like so we try and drag it in here, what happens is because it's very annoying, it will switch back to here, the mutator zone details panel. So a little trick is you can click here and click the little lock symbol, and then that will lock this panel here. So we to go and drag it in like this, and then of course remember to unlock it again when you're done. So a few ways there of assigning it. Now we've got a reference to it, what we can do is we can access those things I showed earlier in the details panel. So we can get the event that the agent enters, agent exits, etc. Let's try and register for the agent enters event. This is when an agent basically is kind of, if you imagine classes being a hierarchy, the agent is kind of like one above the player. So player is derived from some agent. This might be a bit confusing if you don't know about Verse, but basically just an agent is our player, basically. I don't want to give like information overload, like if you know it by now then great, but if you're kind of new and just want the kind of basic guide to Verse, I don't know what, I'm not going to blow your mind up, but let's say we just want to get this event and use it. I'd recommend using the multi-window here sometimes so you can see the things you want to use. Here's a zone dot and then agent enters event dot subscribe. And oops, dot subscribe, and then we need to give it something that will be called when this event is fired. So we need to make a new function. So we've already got a function here, which is on begin. That's one that's given for us that will run when the game starts. So let's write one called on agent enters, and because this is a kind of a predefined template, if you will, we have to give it some default parameters. If you look here, you see it's going to send a type of agent. So we need to accept a type of agent as one of our parameters in the function. Remember, the way we declare, or the way we define things in Verse is we do the name, our friendly name of the variable first, colon, and then the type. What you'll probably see in a lot of things is you'll see someone do something like this, and to the kind of someone who's new to Verse, that is a bit confusing because you're like agent, like aren't they the same thing? But no, one is our name, so I could call this literally anything, and the other one we can't change because that is the actual class that we need to accept. If I do this now and put this here, then that will accept it. If I got rid of this, it would go, hold on, it expects a type of, it's an awfully cryptic message, but it basically expects a type of agent to be accepted as one of the parameters, and we don't have it. I'm going to try and keep this as clear as possible, so let's say entering agent, right? And then let's just print that we've entered. Okay, so also you can do Control Shift and B to build, a little shortcut, the same thing, build your Verse code. What we'd have to do is we'd have to launch a session, wait for Fortnite to load, or upload your island, you'll see it in the log, it takes forever, and then you could walk into that zone and it would print something to the console, so that's great. So let's keep exploring Verse and trying a few different things. So another device that you might be familiar with, you might not, is the trigger device. Kind of similar to the mutator zone, but a little bit more, I guess, focused. So the mutator zone, you can use it for this purpose, but this will, just do it for you. So we can get, say, the on-triggered event, and we can also call this as well. So again, this is another one that can be accessed through Verse. Not every device has all of its events exposed from Verse. A little trick is you can actually use the trigger to trigger those events that aren't in Verse, because you can, like I say, you can call this. So this might be a bit confusing if you don't know much about UEFN, which you probably don't because you're watching this video, but maybe when you do you'll understand what I'm talking about. But it's a little like hack to access some of the methods that aren't actually exposed in Verse. You can use this trigger device as kind of like an intermediate way of accessing them. But anyway, that's not what I wanted to talk about. What I wanted to show you is how it works. Very similar, let's just call it, say, trigger, and then say trigger device, and we have to initialize it with something, so we call it trigger device, like that. If we go look at its available methods, I don't know why it's opened in the same thing, then you can see we've got triggered event, and we can also call, like I was talking about, you can also trigger it manually, and then it will call whatever's subscribed to it. Let's subscribe to this, and if we look here, if you remember the last one, the mutator zone wanted to give us a type of agent without this question mark. Why is this question mark here? So this kind of plays into the whole thing in Verse, and that something can be a maybe. And that might sound very strange because you don't think, oh, computers are either 1 or 0, it's either there or it isn't. But no. In Verse, we can have things that might be of this, but they might not be. And it kind of makes sense, especially in this context when you think about it, because if we call this, say, from here, from in code, then there is no agent because we're running it from our code. So we still have this event that fires, but there's no agent. So this will just be false. What this does is, instead of us referencing something that's potentially null and crashing our program, it forces us to check this type, whether it's null or not. That's what this is. Let's show that in action in case that's a little bit confusing. The trigger dot triggered event dot subscribe, and then I'll make another one called on trigger enter. I'll give it the exact same matching parameters, so I'm going to call it maybe agent, and then it's of maybe agent, I can actually spell, and then we do the, I don't really explain this, but when we write void, that's the return type of the function. So for example, I could write get me a number, and then that would be a type of int, and then if I do return 4, for example, that's fine. And an interesting side note with Verse is you have these things called implicit return, which basically means that if it sees a valid number or valid, I guess, type as the last thing that's in the function, it will just automatically return that. So I can just write 4, and that's valid. It will just return that. It's a little bit hard to read if you're not used to it, but it is something that Verse offers. And if you don't like writing return, then there you go. Anyway, what I was actually trying to show you is if we put this in here, then it will be happy because we've got the right type. If we got rid of this, it will show it's the wrong type. So this is a very we have to be verbatim the exact thing. So how do we work with this maybe type, right? So what we have to do is we have to do if, and then what we do is we basically get the actual type. We see if that actually exists. But the way we can get a value out of this is we make a new variable. Let's just call it agent. So we've got maybe agent, we're going from maybe agent to agent. And then we do this, equals maybe agent, and we put a question mark there. If we can get an agent from our maybe, then we can work with that agent. It's assigned, we've assigned it like this, and then we can do agent dot whatever. There's many things we can do with agent, but for the minute, let's just focus on how this works. So you can actually make these, it might be an easier example, is we can actually make one of these kind of maybe variables ourselves. Maybe, I don't know, maybe we'll do a maybe trigger, why not? And then we give it, instead of being trigger device, we put a question mark in front of it. Trigger device, and we initialize it because again it still has to be initialized to something, so we can initialize it to false, so we say it's not there. I forgot to write device. And the way this will look in the editor, if we go back here and we click on our device, is it says here we can set it to a value. So if we want to have it, we can, otherwise it's just set to false. It doesn't exist. It doesn't matter, and that's fine, because to use this we have to check that it exists. Kind of stemming from this having to check that things have not failed. The Verse is based around, you'll hear the word failure context a lot. It's based around failure. It's based around making sure things succeed so we get the expected results. Building on that, there's a few things, if we try and do them in Verse, it won't let us do them in, I guess, a way that is natural. So let's try getting in just a prop. So the way you can get a prop into Verse so you can manipulate it is we can call it a creative prop, and then we have to initialize it to something. Creative prop, call it constructor. You can do some things with props. So let's say let's just ignore this. Whenever the trigger is triggered, what we want to do is we want to teleport our prop to a position in the world. So how the hell do we do that? We can do prop dot teleport to, and then normally when you call a function you use normal brackets, right? In every other language you just use normal brackets, but in Verse you've got a few, they're what's called effects, and one of the effects is something called the decides effect. What that means is instead of having, say, if this equals this, we could just call if this is successful, call it with these square brackets, and then if it is, we run whatever. So we use that as the deciding factor to our if statement. So because teleport to is something, anything with the decides effect is something that can fail. We can check it and use it to branch in our program. Just to give an example, let's say, so teleport to, if we go look at it, unfortunately the IntelliSense isn't very good, so because we've got an error it won't let us. So I'll have to fill it out, but I'll show you in a second what it actually wants. But it wants a position, a rotation value, position and rotation value. So let's give it those things. For position, it wants a vector 3, which is just an XYZ, a way of holding XYZ. So those are our coordinates in the world, right? Let's make one. Teleport position, try and get it a bit more readable. And then it has a type vector 3, and then we need to give it a class. Now this isn't working, and it's not working because it wants us to include this. I'm not actually sure what Verse calls it, but other languages, they'd probably be called either headers or namespaces or whatever, But we need to include this so we can reference the classes that are in this. I think they're called modules, actually. That's it. They're called modules, yeah, in this module. But we've got a vector3 here, and I can actually initialize this right in editor if I want, or I can make it editable and do it from the editor. But we can do it here, so I can just give it, say, like minus 10. And because it's a float, we have to put the point 0. So floating point numbers, integers are whole numbers, floating point numbers have decimal points. And what's weird is that in other languages, this would actually be counted as something called a double, and a float would have to have the letter F after it. But in Verse, I don't even think doubles even exist. You've just got floats and ints. So we have to initialize each kind of I can't think of the word. I guess property, but each axes ourselves. We do x, did it at that, and we do y. It's minus 10, and then z minus 10. So we teleport to our position, our rotation. I don't want to change the rotation, so let's just do proc.getTransform.rotation. And that's fine. What's interesting is if I got rid of this, we have to check that this succeeds. Decides indicates that a function might fail, so it must occur in a failure context that will handle the failure. But I mean, the thing is that if this doesn't happen, then we're fucked basically, you know. So we don't really care, and it will almost certainly succeed unless we forget to assign the prop. In which case we've probably got bigger problems anyway. So if we don't care about something, we still have to kind of, like it says, put it in a failure context that will, that could handle the error. So that's what I mean when it's a way that isn't necessarily natural. So the few ways we can do that, we could do what I had before and just have an if statement that just doesn't do anything, or we could even initialize it to a in Verse, in other languages you have like a boolean, which is like true or false. In Verse it's called a logic, because Verse is contrarian and cool. Results logic equals, and I think we have to do like this, and we pass it in as the constructor for the logic variable. Or we can do like this. We can do like the kind of like blocks, like if, and then you could handle it like then, and then you could also do like else this way as well. It's another way of handling if statements. There's a few ways you can do it. I think the cleanest way is probably either this or doing this and then just putting this on the end and not dealing with it. So, but it's a bit confusing when you first new to Verse, because you see like if this and then nothing. It's like if what, but that's why, is we have to check. And then another thing you might notice is if you try and do something, if you try and access a variable kind of in line, you'll get an error. I'm trying to think of an example of how I could show this. I'll mimic this method I made earlier. Let's say get me a random number. I really changed my formatting settings, but I don't use VS Code much apart from for this, so it's not really something I bothered to do. We don't have to write return, we just do get random int, and then give it a range of say 0 to 100, and then we'll have to include the module, so we can just copy this and put it up there. My random number is, and then if you want to get like variable values in that are programmatic, you might remember this from when we had that example. We can use these the parentheses, and then we can just call the function like that, and that worked, which is not what I was trying to demonstrate. Okay, let's try this. If get me a random number equals 2, will that work? Right, yes, this is what I want. This says, this invocation calls a function that has the no rollback effect, which is not allowed by its context. Now, what the hell does that mean? What that is trying to say is that it thinks that whatever we're performing in here is, if this fails, because it's an if statement, if this fails then it cannot be rolled back, is what we've told it. That's what that no rollback effect means. And that would be true if, say, I was, I don't know, moving something or teleporting something, or I don't know, writing some data, but I'm not. I'm just getting a random number, right? So how can we get around this? Well, the first way, the simplest way, is to just do this beforehand. Do num equals that, and then I can do if num equals true, and that'd be fine. Or what we can do is go one step further, and we can give it the effect called transacts. And what this means is it's not actually doing anything kind of destructive, it's just getting a value. This would be called a pure function in any other language. In Verse, it's called transacts. And now you'll see if I do this, it will be happy, because I've told it it's happy. Another example, kind of building on what I said earlier about the decides, because I don't think I explained that very well, is we can implement this ourselves. So I can say it decides. So what I can do here is make it of type void and then give it a condition that is more than 20, for example. Right? So what happens here is this will decide true if this is true, right? So what I can do here is get rid of this, and because it uses the decides, it will say I have to call it with square brackets like this. And also we can say it transacts. Right there. So now we can use this as a way of kind of building our condition, and we can use this decides effect and the transacts effect to kind of work with these things. So I hope that's explained it. It is very hard to get your head around when you're new to Verse. There's one other thing that I wanted to discuss in this kind of like onboarding guide, and that is something you may run into as your code, as your project gets bigger, and that's the idea of circular dependency. So what is that? Well, if I go into my C++ project again, and I'm going to have to build it up again quickly. If we go into here and we say include, so imagine this is exactly the same sort of thing as I'm already using here, same thing. So we want to include, and we give it the file name class2.h, right? And then what about if we go in here and we say we want to include class1, right? So this is saying it needs this, this is saying it needs this. So this is what's called circular dependency, and we can't do it. If I try and build this, it will probably get mad at me. I think it's still mad about that other thing. Let's get rid of it. Okay, I think it's because I didn't actually put any variables in there. The point is that we shouldn't do this. This is bad, right? This would cause issues. So the same thing happens in Verse. If I let's make another Verse class. This will cause issues. So I want to include that in here. So let's do my device to initialize it. Okay, that's fine. That will work fine. But then, what if I then go into here and I go, ooh, but I want to access this device from here? I do the same thing. So I make a field of my device again, but this time of example device. So again, it lets you do it. It's fine. It should be fine. And I could use the functions that are in here and whatever. All great, right? Well, no, Verse still doesn't like us doing it just because it's not a very mature language. The way it handles it is, well, I'll show you. If we go and try and build this program, so let's go up here, build Verse code, and we crash. And if you're not new, if you don't understand what we're doing, and I wouldn't blame you because it's, especially if you're not a programmer, then this isn't very helpful, right? But the problem is what it's mad about is that we've told it to, we've got circular dependency. We said that this depends on this, but this depends on this, and it goes, what the hell's going on? I don't understand, and then it just crashes. That's the problem. If we try to reload this project again, it would still keep crashing until we deleted one of these from there, and now it will load up fine. I don't want this video to go on any longer, really. This has just kind of been like a basic guide. I hope I haven't been too technical for people who don't know anything about programming, but I also hope I haven't been too not technical, people who do. But anyway, I hope this was helpful for someone, just because Verse is a very weird language, and I feel that UEFN is only going to get more and more popular. Yeah, more and more people are going to be picking it up for various reasons, and that's why I wanted to make this. So yeah, thank you for watching.